We're taking a look at OSPF LSAs, link state advertisements. How many are there? Well, find out next, right here on IT Pro TV.
You're watching IT Pro TV.
All right, we're about to jump into OSPF LSAs. It was one of the very first topics that I remember as a CCNA looking at and going, I did not know that there was this much to it. But the guy that does know, Anthony Sequeira. So Anthony, as we jump in, this is probably the first big jump beyond the CCNA that really begins to intimidate that particular student when they go, I now know I can set up a routing protocol, I can set up OSPF, I can show you all of the actual show commands, and then you start talking about LSAs and all of a sudden you see their face kind of drop a little bit. And then you go, oh, there's a handful of them, and then you start talking like, are you joking? There's all this stuff. So Anthony, help us out here. What are we actually going to be taking a look at?
I kind of can't blame our students here. I mean, this is, we dig deeper into the protocol and it's like, why? And to some degree, I get it. There's some of the show commands that we're going to be using in this episode. It's just not all that common that you would be using them. They are often used primarily for learning, but that's okay. Like nothing wrong with that. So let's jump in. What we set up for you here in today's episode is this simple 5-router topology. And where we're going to be doing our work in this episode is let's set up the backbone, Ronnie, on R2, R3, and R4. So those three devices, the links between them shall represent our backbone, our area 0 in OSPF. And we'll take a look at the LSAs that get generated inside of there. In the next episode, we'll go ahead and add areas. We'll do a normal area between R1 and R2 and R5 and R4, and then we'll see the LSAs that get created there. We'll do another OSPF episode for you, by the way, on the potpourri of additional features that are out there. So let's jump in to the command line right now. We want to go over to the R2 device. That's the first device making up the backbone.
All right.
And Ronnie, if I do a show IP interface brief, I'm going to see that we have the 0/2 interface on 10.0.0.9, and that connects over to the R3 device.
All right.
I could, I suppose, do my show CDP neighbors if I had enabled CDP, but I didn't. So we'll just have to trust my memory of the topology and see how we do here.
All right.
So Ronnie, you pick.
Okay.
Shall we do our OSPF via the network command on this device, or do you want to do it via the interface?
Well, let's do it through the network command as a short review for everybody as they get started, and then we'll show you another way to configure it.
All right.
Probably my favorite way to actually configure it instead.
Router OSPF Lucky 777. Remember, we can use anything here for the locally significant process ID, but I wouldn't do what I just did. And the reason why is you're going to forget that you set some kooky number like that, and then you won't go in and configure the right process. So I'll do router OSPF 1, and I'm then going to do the network command per Ronnie's specification, and I will do my favorite approach if I were in like the Encore exam or the CCIE lab exam. I would do the all zeros wildcard mask, so I'm very specific. So I would go, all right, I want OSPF on 10.0.0.9, and then I would say with the wildcard mask, precisely that IP, and then I would do my area. Let me spell it out. I usually do A_0, but for learning, let's spell these commands out. And there we go. There's OSPF just on that one interface. And then I would do an up arrow because I'm now going to go in and do the 192.168.0.2, my quad zeros, area 0, and there it is, OSPF on the loopback interface. So that looks good, Ronnie.
Right.
We can end. I would save at this point, and then we would slide over to router 3. We'll do one more network command example. I'll do router OSPF 1. I will do network 10 0 0 0. So let me back up. We're going to do show IP OSPF brief. Do
Interface brief.
Show IP interface brief.
Yep.
Whew. Okay, so here we have the connection over to R2, and that is the gigabit 0/1. And then the connection over to R4 is gigabit 0/2. So I will be lazy here, and I will go network. If it starts with 10, go ahead and run OSPF on it. So see that command? So Ronnie, if 10 is in the first octet,
Right.
Now think like a router. What should happen? Boom.
Right.
We should get an adjacency. R2 was configured for OSPF. Now R3 in that direction is configured for OSPF. We just got a neighbor adjacency just as we would expect. Now I need to do my loopback. Don't forget your loopback.
Right.
And I'll be lazy again. If it starts 192, go ahead and run OSPF on it for area 0. So we'll end, we'll save, and now one last router. And on this router, we'll try the interface configuration. So router OSPF 1. And we are going to do network. Oh, no, I said we're not doing that. In fact, I don't even want to do it this way. So get out of router OSPF configuration mode, and we're going to go under the interfaces. Do show IP, do show IP interface brief. So we need the 0/1 interface here. So I'm in interface configuration mode. I say IP OSPF, the process ID of 1, area 0. Think like a router. When I hit carriage return, within seconds, we should get an adjacency. And if that doesn't happen, then you can fire up your troubleshooting. But I'll end and I'll get ready to save. Where's our adjacency? There it is. So notice how we're thinking ahead of what we expect to happen. And we have just built our backbone, Ronnie.
Yeah, now this is probably one of the ones that we don't really demonstrate, at least at the CCNA level, which is configuring on the interface. But this is my favorite approach because it means I don't have to worry about the network statements to get those paths directly connected.
That's right.
Now, so I actually like this because even if the IP address changes on the interface, the OSPF is still set up.
Boy, I never even thought about that, but you're absolutely right. And notice what I did with the quad 0 wildcard mask. I essentially was trying to do it interface by interface.
Yeah, and so it's a great way to actually do configurations and a little bit faster if you're not good at wildcard masking. So if you're like me, the first time you're there, like, oh, I don't know, and you try and figure it all out.
Sure.
So this is another way, and just 4 simple commands there: IP, OSPF, process ID, and then area space, whatever area you're going to do. Ours is 0. And it's up and running. And all you have to do is connect the other end, and you're good. As long as it's in the same subnet, you're pretty much good.
Now, I've mentioned several times in these Encore episodes about how I kind of have my primary troubleshooting tools and then kind of the secondary tools. Well, what's a primary troubleshooting tool with OSPF? Oh boy, let's take a look. Without a doubt, it's show IP OSPF neighbor. If I had $1 for every time I've run this command.
Great command.
Yep. So here we are on R3, right smack dab in the middle of the area 0. And you can see that I have a adjacency with the R2 router, neighbor ID of 192.168.02. And then I have my adjacency with the R4 R4 router at 192.168.04 for a router ID. Now, one of the things that we wanted to really highlight in this episode is our link state advertisements. We remember that OSPF devices are sharing these link state advertisements with the neighbors on an area by area basis, and they use this information to construct their own atlas, road atlas, like our old school Ronnie was talking about before the invention of GPS in the car. So they build this atlas or map of the network based on these LSAs. How we view the LSAs, a couple of different ways. Certainly, one of our primary commands is show IP route OSPF, and we're going to see that we have this entry in our routing table for 192.168.02. That's one of the loopbacks, and that just reminded me I've got some troubleshooting to do, because where is the R4 loopback?
Ah, right.
I forgot to advertise it. So we're going to go over to R4, and this is where we did the interface by interface config. I need to do interface. Well, let me do this. Do show IP interface brief. It's loopback 0. So I need to do interface loopback 0 IP OSPF area, process ID 1 area 0. There we go. And we'll save that configuration change. We're going to go back over to the R3 device. We will rerun our show IP route OSPF, and there's the both loopbacks that we expect to see. So those are LSA entries that have appeared in our routing table. But if we want to see all of the LSAs that make up this area, Ronnie, I would do, or at least that this router knows about, I would do this. Show IP OSPF database.
Right.
Now, this is one of those commands that is not by any stretch of the imagination a primary troubleshooting command for me. But this is an awesome command for learning OSPF. So we can see, Ronnie, that for process ID 1 OSPF on this router with the router ID of 192.168.03, we have LSA type 1s and LSA type 2s. Those are those fundamental building block LSAs of the area. The router link states, the type 1s, it looks like if we scrutinize those, it is the entries for prefixes that are inside of our area for each of the devices.
Right.
So we said that we saw this entry inside of the routing table and this entry inside of the routing table. Sure, those are intra-area OSPF entries for those remote prefixes. And then the net link states are our type 2 LSAs, and these are generated when we have Ethernet, when we have multi-access broadcast-based media like Ethernet. This is the DR
Right.
saying, hey, I'm the designated router. Here's all of the devices that I'm going to be sharing information with in that whole DR and DR other and BDR relationship. By the way, we saw that when we looked at the neighbors, didn't we? Show IP OSPF neighbors, we can see that we are the DR for one of these relationships, and we're the BDR for the other relationship that we have with our neighbors.
Yeah, one of the key elements that I know that is easy to forget is essentially just saying, look, inside of the LSA type 1s and type 2s that we see up there on the screen, or that we were just seeing up there on the screen, those are only within that one area. In other words, they're not going to go across different areas that we might set up. They're only going to stay in that one area. And then with the type 2 is to remember that, at least for me, is to try and say only DRs are going to be issuing that. So as long as you have that, I think you can kind of easily remember that you're going to do that. But every router has the type 1. Okay, every single router has
cool.
it. Yeah.
So if we didn't have any Ethernet,
Right.
if we were all serial and we didn't have any DRs or BDRs, we would have no netlink states,
Correct.
no type 2 LSAs.
Right.
Yeah, and another thing too is, look, these are easy to read. So Ronnie, this is pretty cool. It looks like our 192.168.02 is a DR, and it is saying, hey, look, I'm the advertiser here, and I have a 10.0.0.9 entity that I am feeding information to.
Yeah.
So pretty easy to read. And when we look at our type 1s, here is 192.168.02, our neighbor. It's the advertising router. And what is it advertising? Well, that 192.168.02 prefix. Remember this too. Quick little aside. Now that we're really getting a sense for these awesome LSAs, remember that oddity that happens with OSPF, right? If I do a show IP route OSPF, we see that these are what? They're 32-bit host routes. So OSPF has this kind of annoying, quite honestly, little feature where anytime you're advertising loopbacks, it does a full 32-bit host route. There's lots of ways you can fix this. And the one that I most often do is, I'll demonstrate it on one of the routers here. I go in and you just change the network type. This is probably how you do it, right, Ronnie?
Right.
You go interface loopback 0, IP OSPF network, and you can just set it to like point to point. When you make that change, now it's not the type, the network type of loopback, which triggers the 32-bit advertisement. And now what you're going to have, if I refresh our look at the routing table, is once convergence happens, we should see it as the 24-bit mask. If you don't want to wait, I can do clear IP OSPF process, and I can say all of them. Nope, doesn't let me do that. You just say clear IP. Oh, and it says all of them, and I say yes. And now it's going to force a rebuild, a resharing of the LSAs, and we should see show IP route OSPF. We should see it come in. Why is it not coming in as the 32-bit, as the natural mask? This is interesting. Let me go take a look at R4. So show run interface loopback 0. I have IP OSPF process ID 1, area 0, IP OSPF network point to point. I think that should have done the trick. Let me do a show IP OSPF interface. And let's look at the loopback. For the network type, it says point to point, not loopback. So it should be advertising that as the 24-bit. Oh my gosh, is this funny? Look at this, Ronnie. Do show run interface loopback 0. They put a 32-bit on it. Viral did. Hilarious. So it's like, hey, it's a 32-bit host route. Yeah. We'll change that. Let's go interface loopback 0. And we're going to do IP address 192.168.0.4.255.255.255.0 and save. If we come over to our R3 device and we rerun our show IP OSPF route, it is now with the 24-bit mask. And remember, it would always show up as a 32-bit, regardless of the mask length, if you don't go in and do a little trick like change the network type like we did. I just stumbled into, I wish Ronnie hadn't seen that, because when I start giving him troubleshooting tasks for OSPF, That's a fun one to do.
Yeah.
Go ahead and give the loopback a 32-bit mask. Say that you can't have, the host routes advertised, and he might trip into just what I did of fixing it and then seeing it's not fixed. What's going on? So that's a fun little troubleshooting one we stumbled into there. Ronnie, anything else that you wanted to show at this point in our OSPF deep dive? We've built Area 0.
Right.
We've taken a look at those LSAs that we would have, did a little troubleshooting.
Yep, and the show commands that we needed to so that we could see everything. That sounds pretty good, but we still need to actually kind of do some more LSAs, but we are going to be heading in.
Yeah, so we've only looked at type 1s and type 2s.
Right. So we've got a couple of more that we're actually going to be doing, so we're going to pick up on the next episode. But remember in this one, on the type 1s and type 2s, they're going to stay within the area. Okay, they're never going to actually cross the area boundaries. Every single router that you run in OSPF will always give you a type 1. So no matter what, if you actually do get that, like, hey, there are all these routers that are running OSPF, and it says, what LSAs do they produce? They'll have a whole list for you. Make sure you at least pick type 1. If you actually get a type 2, remember that only comes from the DR, and if you're in an Ethernet environment, as Anthony said. But there are more LSA types for us, but we are going to take that in another episode. So that is enough for this one. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
I'm Anthony Sequeira.
Stay tuned right here for more of your Cisco CCNP Encore show.
Thank you for watching IT Pro TV.